Go ahead and start the official seminar. Welcome to the Exida web seminar on the Exida certification scheme. As probably the world's leading accredited certification body in the process industries, Exida has established a certification scheme. And what we're going to talk about today we're going to talk about that certification scheme today. And for those of you who are product developers and manufacturers, program or product managers, we can talk a bit about the kind of things you need to do to get a certification. If you're an end user, we're going to be talking about the kind of things you need to do, or the kind of things manufacturers need to do, and how those things benefit you as an end user. My name is Bill Goble. I have over 40 years of professional experience, and the last 25 years has been heavily involved in reliability engineering and safety analysis. I do spend a lot of time in the certification world, originally as a product manager, getting products for which I was responsible certified, and then in the last 12 years actually doing certification work for other people. I work for the company called Exida. We are a group of people that have a lot of people from a product development background, like myself. We have a lot of people from the safety certification background, primarily people from one of the TÜV companies out of Germany. And we have a whole lot of people that come from end users, primarily chemical, petrochemical company, and we all work together to come up with programs to help the world of functional safety. At Exida, our procedures, our methods, and our data are all published in publicly available books. We supply these books to our customers, to our competitors, and to anyone who wants them, because everything we do we try to make public. I'm pleased to say Exida has authored most of the industry references ever published on automation, safety, and reliability. The subject today is primarily IEC 61508 certification. The fact is, systems, products, and components are getting certified. The end result of this certification process is a certificate. At least an Exida certificate looks a lot like this one, listing the SIL level for which a product is qualified and the standards that were used in that certification. The primary objective in IEC 61508 certification is a demonstration of high design quality, both for hardware, software, mechanical, and high manufacturing quality. Now, when you think about it, it's a whole lot different than ISO 9001, because in all my experience with ISO 9001, you primarily focus on the manufacturing, procurement, and delivery process. 61508 is very focused on the design process, and we spend a lot of time focusing on how well a product is designed. Why? We want to make sure we have sufficient protection against latent design flaws that could have a very significant impact on safety and availability. There are several companies in the world that have been accredited to provide IEC 61508 type product certification. All product certification programs are typically run under a set of two standards, ISO IEC 17025 for a test laboratory, and EN 45011, which is IEC Guide 65, for the requirements for running a product certification program. Every country in the world, typically, well, most every country in the world, has an appointed accreditation body. Most accreditation bodies are members of the International Federation of Accreditation Bodies, and as such, they compare notes on how this is done. Most accreditation bodies are governmental agencies. In the United States, the accreditation body for functional safety is ANSI, the American National Standards Institute. ANSI and the American Society of Quality have formed a merger and provide accreditation per IEC 17025 for test bodies. Now, and the bottom line is, any company who wants to be a CB, a certification body, in the United States must be accredited by ANSI in order to do 61508 functional safety certification. Exida has been accredited by ANSI and A-Class for this kind of work. Now, in fact, Exida strives to operate the most relevant and useful product certification program in the world. And I mean relevant and useful to those who purchase the products that are certified. In the process industries, Exida does this by having a group of engineers out in the field working on real projects all the time. And the second thing we do is we have established an advisory board. It's a group of approximately 15 end users from around the world. And they review the Exida certification scheme and all the requirements and make suggestions and help us with interpretations and deal with any complaints against the Exida certification program. It's a very valuable group because over the years they have expressed serious concerns with existing certification programs and have told us that if we ever expect to succeed as a certification body, we need to do a better job. So we listen. The Exida has created a functional safety and cybersecurity product certification scheme. That's a funny word, scheme. Now, scheme means a set of requirements. A set of requirements that ANSI will use to audit Exida. And the set of requirements lists the standards for which you will hold a product, the standards that you will use to establish product requirements. And at Exida, we primarily use IEC 61508 and the approximately 1 dozen derivative requirements, industry-specific requirements like machine safety, automotive, nuclear safety, and so on. And we've recently added the ANSI ISA EDSA 300, known as ISA Secure, for product-level cybersecurity. Obviously, cybersecurity only applies to products that might be susceptible to cyber attacks. But today, that's a real concern. So when Exida is certifying a logic solver, we include cybersecurity threat analysis in the certification program. In addition to those standards, Exida has added requirements above and beyond based on the advisory board recommendations. Exida always does an FMEDA analysis. Why? End users really want and need accurate failure mode data. The FMEDA analysis technique provides data far more accurate, especially in a predictive mode in a newly designed product, You get failure rate data that will take years to accumulate if you were waiting to gather up field failure statistics. The exida scheme requires analysis and publication of false trip data. Those of you who are product managers and are involved in the world of safety instrumented systems probably know and understand quite thoroughly that end users care not only about safety, but about false trips. Those of you who have ever worked in an operational chemical or petrochemical plant thoroughly understand the impact of a false trip. First of all, a process shutdown may create dangerous conditions. And secondly, it certainly has a major impact, especially when a plant is operating near capacity. The IEC 61508 standard has absolutely no requirements on product availability, and yet end users very much care about that. So at Exida, we analyze product availability and include in our published results not only the safety parameters, but false trip failure rates. Why? Because end users need this information, and not every, in fact, most other certifications that I've ever seen have nothing to do with availability. Exida evaluates the maintainability. How easy is this product to maintain? Has the manufacturer made it easy to maintain and calibrate the product? How complex is systems level design? End users on our advisory board have made it very clear that they were quite unhappy with other certificates issued by other certification bodies when those certificates require the end user to mount multiple redundant modules and hand wire them together and then program voting schemes. I mean, some of this stuff, as far as I know, it started with this, well, I better not mention any names. There are product certifications on the market that are very complex to implement at the systems level. And this sort of thing is something that is not acceptable to the Exida certification program. We evaluate whether a practical proof test is possible. If a manufacturer is responsible to recommend proof test requirements, at least that's what the end users of the world in the process industries tell us. Because when a manufacturer requires a totally impractical proof test, you know what happens. It never gets done. And that's dangerous. Lastly, the Exida certification scheme requires what are called surveillance audits. And we publish expiration dates on the certificate. I have noticed that some of our competitors are starting to do that since we did, but not every certificate has such a date, even today. The bottom line is that we work very hard to go significantly beyond 61508 requirements to provide a certificate with more information and more value to end users. Any questions or comments? Let me just reinforce the note on the very first presentation. Anytime you have a question, a comment, a challenge, you've heard something that contradicts what I say, please type it up using the Q&A tab, and I will look for questions and answer them as we go. We're doing just fine on time. All right. There's also an issue of what kind of components, what kind of products are covered by IEC 61508. I mean, if you read the standard, it clearly says E/E/PE. And E stands for electrical, the second E stands for electronic, and PE stands for programmable electronic. And it's absolutely a fact that a lot of the attention especially in the entire Part 3 of the standard is focused on programmable electronic systems and software engineering requirements. And many people have concluded, therefore, that 61508 cannot be used and is not applicable for mechanical products. However, it's very applicable, and in the exida certification scheme, we include electrical, electronic, programmable, electronic, and mechanical components. And the reasoning is very simple. 61508, the 2010 version, even specifically says in Part 1 that a system may also, that this standard requires a framework for which safety-related systems based on other technologies, like mechanical, may be considered. There's a specific question on the IEC website on this, and they say that, of course, if an E/E/PE system has mechanical components, then you must include them in your analysis. And in bottom line is it's simply not possible to meet the requirements of IEC 61508 and industry-specific standards like IEC 61511 without including all mechanical products. So in order to help people do this, Exida does include and does a lot of certifications on all of these kind of products, including mechanical. For example, a pressure transmitter. How many people even know you could buy a certified pressure transmitter? Well, quite frankly, in the mid-90s, you could not. But today, Yokogawa, Rosemount, and probably a half dozen other manufacturers have been given a SIL 3 capability rating by Exida. Now, in order to do that, they had to establish or make sure their existing development process meets all the SIL 3 requirements. Why is that? We want protection against systematic failures. They had to add features to the product to ensure protection of the data. Typically, many of them added features to detect CPU execution problems to meet specific requirements of 61508, and all of these things are meant to protect against design mistakes, particularly design mistakes in the software. As an ex-software developer, I tend to choke on that because it's hard sometimes to deal with all these process requirements. Many of these manufacturers added automatic diagnostics to the product to detect most hardware failures. All of them had an FMEDA analysis done with fault injection testing and a field failure study done in order to verify and make certain the accuracy of the FMEDA analysis. And of course, they created a safety manual to explain the usage of the product. Now, many of these devices are meant to also protect against random failures. Recall that 61508 wants to provide protection against both systematic or design process mistakes as well as sufficient safety integrity against random failures. We want to cover both, systematic and random. Solenoid valves are certified. ASCO, Bifold, Versa, and many other manufacturers have been given a SIL 3 capability rating by Exida certification, and they had to establish a hardware development process that meets SIL 3. Of course, there's not nearly as many requirements if they don't have any software. Demonstrating test results that prove they are following the process. They created a specific user's manual explaining the usage of the product, and FMEDA analysis was done on their particular product design, backed up by a fault injection test and a field failure study to give very accurate failure mode and failure rate data for end users. Any questions so far? Don't hesitate to ask. Oh, here's one coming in. What does SIL 3 capability mean? All right, that's a good question. The term systematic capability was defined in the 2010 version of 61508. That term was not in the original first edition. The term systematic capability means that the design, development, test, and documentation processes meet the requirements of a given SIL level. So SIL 3 capability means the design, the development, the documentation, the archive, the review processes meet the SIL 3 requirements of 61508. And SIL 3 capability, as the original term systematic capability means, a product is sufficiently free of design defects to be used in a SIL 3 application. And again, I'll repeat, this is a rather new term defined in the 2010 version of the standard. It is a good question. Thank you. Again, we want to protect against systematic and random failures. Even actuators and valves, for example, Fisher Controls and many others have been given a SIL 3 capability rating by establishing a proper development process for that hardware, demonstrating test results, proving they follow the process, doing an FMEDA analysis with fault injection testing and a field failure study, and creating sufficient user documentation to explain the usage of the product, covering both systematic and random failures. Now today, if any of you have not checked, there's a large number of products of many different types that have been 61508 certified. The primary reason for that is that end users must justify all equipment used in safety instrument and function designs. And 61511 gives them two ways to do that. They can do their own prior use justification, or for safety integrity, they can buy products that are 61508 certified. Many end users are going in that direction because, number one, they don't want to do the work to do a prior use justification, and they don't want to take any responsibility by signing any prior use justifications. It's amazing the different kinds of sensors that you can get today. Main primary process sensors, pressure, temperature, flow level, gas detectors, flame detectors, BMS flame detectors, vacuum. All kinds of products are now available today. Of course, PLCs, that was the original certification concept. But today I can even get trip amps, isolation modules, intrinsic safety barriers that are all 61508 certified. And certainly on the mechanical end, I can get actuators, solenoid valves, quick exhaust valves, and all kinds of process valves, ball valves, gate, wedge, many butterfly, all kinds of different technologies are available in a nice assortment of 61508 certified products. You can take a look at one list, the Safety Automation Equipment list on the exida website. Let me type in that address. L-online.com. Anytime you want. Maybe after this seminar, not right now. I only have a few minutes left. Type in sael-online.com and take a look at all the different products that are available. You'll see lists, like the list for pressure transmitters. There's a strong trend toward 61508 certified products. This is a chart for sensors of all types. The first one, to the best of my knowledge and research, was Endress and Hauser back in 1996. It was a level switch with a vibration fork. And it had a nice fundamental fail-safe design. Certified by, I think they were called TÜV Product Services back then. It's today called TÜV Süd. And nothing. No other products during 1997. In 1998, more products companies certified a pressure transmitter. And then nothing for 2 more years. Another sensing device got certified in 2001, another one in 2003, and then 2004, a couple more, another one, and things didn't really take off until 2007. And sorry I didn't get the chart updated, because the list of certified sensing devices is growing in a very non-linear way. That's very characteristic of the entire market. If you go to the safety automation element list and call it pressure transmitters, you'll see an updated version of this slide where you can see on this particular slide there were 4 different manufacturers, 5 different products that have been 61508 certified. I can see this slide is a little dated. Nice though. Today I think there's more like a dozen. I haven't looked for a few weeks. You might look at the solenoid valve list and you'll see many different manufacturers and literally over a dozen different choices of families of solenoid valves that have been 61508 safety certified. Same thing for other mechanical products and PLCs. If you look at the PLC list for logic solvers, you'll see not only the functional safety certifications, but the cybersecurity certifications that have been finished as well. Now, what does this mean for product development? I spent a lot of time talking about the design process and the need for high design quality. The essential requirements are any product or any group that develops a product, hardware, software, mechanical, needs a documented process for their work. We call it a life cycle, but it just means what is the development procedures? What are the development processes? You must have a requirements document. You must have a validation plan where you test in a fully traceable manner that every requirement has been implemented. And you certainly need design documentation, starting with a defined architecture. It's typically a set of boxes with interactions. Of course, you have to have good design documentation so that people who make changes can make those changes without messing up the safety. You need a qualified set of tools, especially any language compilers. I've always thought that craftsmen who really do a good job thoroughly understand how their tools work. I remember my father-in-law, who was an excellent woodworker, would explain to me how these tools work before I was allowed to use any of his tools. And I thought I knew how the tools worked, but after I was done, I sure understood a whole lot more. He was right. People need to thoroughly understand how their tools work. So in the world of, same thing applies to professionals, not just woodworkers. And 61508 requires that those who use engineering tools thoroughly understand how they work. You need engineering guidance documents. And one of the most important is the software coding standard. You need to follow all of your development procedures. And the group or the person that does the outside assessment has to see the evidence that you are following all the development procedures. I hope that sounds almost trivial when I said it, but you just won't believe how many times I've gone into a company after reading their development process, and it really sounded good. And I get in there and talk to the people doing the development work, and I ask, okay, show me how you actually designed this product. And they would draw some pictures on the whiteboard and describe the steps they follow and the tests they perform. And then I said, yes, but that drawing you just made doesn't match the procedure. Oh, that procedure. Those guys from corporate made up that procedure. Nobody ever follows that. And I go, oh my. So I think we, obviously, quite frankly, they did not pass. In the world of 61508, you need to verify compliance to the coding standard, to your development procedures, and all process requirements. Now, what's this look like? Well, the bottom line is if I categorize all the requirements, there's 5 main categories. For your hardware, you have to have relatively low failure rates and a certain amount, or possibly a fail-safe design, or really good automatic diagnostics if you have a smart microprocessor-based product. And if you have those things, you'll probably meet an important metric called the safe failure fraction requirement, which you must do to get a particular SIL rating. Number 3, and you can see that I have that red and bold, and that's because it's the hardest way. It's one of the hardest things to do. Quite frankly, a lot of people have very good hardware and electronic hardware and mechanical design processes in place. They have very good tools with lots of experience. But the same thing doesn't always apply to the software engineering world. In that world, there's a lot of people still doing things in a less than high quality manner. That doesn't work in IEC 61508. All that stuff will fail. The product itself hardware has to meet good design processes, and of course you have to have sufficient user documentation. Now when I look at the whole situation, I think, what's the barrier? Going into a project, there's a small barrier for your hardware issues, number 1 and number 2. But the big barrier is 3 and 4, getting the design process certified. I'll have to tell you that, at least with the exida certification scheme, over half the people that start fail because of this particular barrier. The alternative, of course, what one must do at that point is improve their processes and use those improved processes to design a new product. Lastly, there's a small amount of barrier to create the user documentation, and actually going through the audit isn't much of a barrier at all. Of course, given that big barrier number 3, you would expect it to be much easier for a simple mechanical product, and in fact, it is. Most mechanical products and even simple electronic devices are much easier to get certified. It doesn't mean the certification isn't valuable. It just means it's a lot easier because there's no software. The exida assessment and certification scheme, we call it an open scheme because we make the assessment products and process and the requirements publicly available. We have them written up. They're on our website, and of course, we present them in web seminars just like this one. We require that the assessment report and the certificate be publicly available, and we require that the certificate and the assessment report be published on the exida.com website, specifically on the safety automation element list. for any of the products on the list that have been certified by Exida, you can go get a copy of their certificate and their assessment report. Really. Now, some manufacturers don't like that, and most other certification bodies do not require that. But at Exida, we feel this is an important part of an open certification process. A typical certification process for a programmable electronic instrument looks like this. You start a project. Often, you will find out if a gap analysis is required. If it's a brand new project and a company has never done a certification before, a gap analysis is a pre-audit. It's a very valuable technique, and so often a gap analysis and some initial training is done. If that gap analysis shows there are any areas of weakness in their development procedure, the customer must correct the gaps. If any specific training is required on, well, what do you mean a coding standard? Specific training can be done to make sure everyone understands what's necessary to succeed. At the same time, a classic FMEA can be done. Of course, many of you who have been in the reliability engineering world know that an FMEDA is a classic, decades-old, and well-proven technique to find design problems and to verify requirements. It's typically done at a block diagram level, and any functional problems are identified, and of course, actions are taken to fix them by changing or improving the design. Given an FMEA, where you thoroughly understand the implications of functional failures, an FMEDA is done by Exida in the Exida certification scheme, because that provides very detailed failure rates and failure modes. I'll talk about that a little more. Often we do a software criticality analysis and software HAZOP, and if any digital communication protocols are used in the safety critical portion, we will have to do a communication protocol analysis, because there are some very specific requirements in 61508 for using digital communications to transmit safety critical variables. All of the process information is entered into a baseline safety case. All the specific details and the analysis work is entered then along with the process information into a final safety case, along with many sets of evidence documents like a functional safety management plan, safety requirement specifications, a validation test plan, documented tool justification, the documented software design process and coding standards, documented software module testing, software integration testing, and a safety manual. All of these evidence documents are also linked in to specific requirements in the safety case. When the safety case is ready to go, an independent auditor from Exida, someone who was not involved in the prior assessment, will audit the safety case, and if all requirements are met, a certificate is issued. The documentation output is an assessment report and a certificate. Okay, here's a question. What is a software HAZOP? That's a pretty good question. I like to call it, the software HAZOP is a software equivalent of an FMEA, failure mode and effect analysis. You typically look at a given design. You can even look at the hardware and software together. And a block is drawn showing a particular function within the design. You either use HAZOP guide words or known functional failure modes to establish a list of the functional failures of that block. And for any given functional failure, you trace through the system design and determine how that functional failure mode will impact the entire product or the entire subsystem. And for results that are not acceptable, then you have to make recommendations as to how to improve the design. So in effect, it's a software FMEA. And like any FMEA, these techniques have been proven over many years to be highly effective in finding design flaws. The big problem in the software world is a whole lot of people don't even know how to do this. They've never even thought of applying the FMEA technique to software. But it is effective and it does work, and we typically do this as part of the exida certification scheme. In some cases, our customers do it, and we simply audit the results. That's a good question. Thank you. Obviously, for those of you who are product managers for a simpler product, like a simple electric, electronic, or mechanical without software, there's a lot of steps and a lot of documentation that's just not relevant. That's obviously why the barriers are much simpler. But nevertheless, there's also a lot of real meat in a 61508 certification for a simple mechanical component. An FMEA is sometimes done for a complex design, but most of the time it's for a simple device, we skip it. An FMEDA is done, and accurate failure rates and failure modes are determined. An FMEDA provides information with a lot more resolution than you'll typically get from any field failure collection system, and a lot more accurate. FMEDA reports are written even for simple mechanical parts. Fault injection tests are done. There's still a safety requirements specification. There's still valid test plans. There's still tool justification required, and a safety manual and an FSM plan. Now, the safety case ends up being a lot simpler, but there's still a full-blown audit. And when they pass, we still issue an assessment report and a certificate. So many of the things are the same. It's just that it's a lot easier when there's no software. We talked a lot about FMEDA, and for those of you who want to dig in a little more, we just did a web seminar 2 days ago. All of those web seminars, all the exida web seminars are recorded and available online. So if you want to go see lots of details about an FMEDA, what is it, how it works, please go listen to that recorded web seminar from a couple days ago. But it's a concept of using a component database and looking at every single part, one part at a time. Now, that might seem unbelievably tedious and boring even. And I'll admit I felt that way. But it's very detailed and very systematic, and it gives you great insight, and it gives you a product failure rate based on the design parameters. More importantly, it identifies significant ways of improving a design. It identifies all the product failure modes relatively accurately, any diagnostic coverage measurements, quantitative measurement of diagnostic coverage, which is very important if you're using a smart device with any automatic diagnostics. You got to understand, how good are these diagnostics? The FMEDA is very much based on an electrical and mechanical component database, and the exida electrical mechanical component database is based on over 20 billion hours of field failure history. Another way to get failure rate data for a particular product, at least a total failure rate, is to do a cycle test. The cycle testing method is valid, but it's only the hidden assumption in cycle testing is that a product is actually used in an environment where it's constantly moving. Because the hidden assumption is that the random failures during useful life is due to premature wear out. Because at the end of the day, cycle testing is designed to determine when a mechanical part wears out. That was all developed to determine that particular number. Now, there is a way of estimating random failure rate during useful life when the failures are due primarily to premature wear out. And you can obtain a total failure rate based on the cycle test. And there are certifications on the market which are based on cycle testing, and you can usually tell by looking at them because they often have the assumed demands per year. In this particular example, the analyst assumed a minimum of 10 demands per year. So the results are allegedly valid for any application where the product moves at least 10 times per year. I will say that when I looked at this, I was a little misled by the term low demand mode, because in fact 10 cycles per year is not low demand at all. But let's ignore that for now. Exida will do, and our scheme allows us to do cycle testing, but we will not scale those results for any cycle period more than 1 week, because all of our research shows that you need at least 50 demands per year before failure rates due to stiction and cold welding and corrosion and so forth occur. The Exida certification scheme will use cycle testing when it's appropriate, but we will clearly identify that it's for high demand only. The Exida certification scheme uses a safety case where all the safety requirements are listed. For every safety requirement, we make an argument based on the actual design. And for every argument, there must be evidence showing that the argument is valid. An independent auditor will evaluate the safety case, and the result of that is an assessment and a certification, if, of course, the independent auditor agrees with every argument and finds the evidence to be satisfactory. A lot of certification bodies do not use the safety case because, as you might imagine, it's quite tedious, detailed, time-consuming. But it's a matter of completeness. It's a matter of doing a thorough job, which we feel is very important. Perhaps even more important than accreditation is competency. I think functional safety is a tough subject. I think the IEC 61508 standard is quite complex and hard to understand. I will admit that many of us debate the exact interpretation of some of the sentences and spend a lot of time thoroughly understanding how this standard applies. I'm proud that Exida has probably as much or more functional safety certification experience than any other company in the world. If I include our people's experience when they were part of another company. If you look at Exida certificates, you will sometimes see that the people who used to do certifications for one of the TUV companies are now doing the certifications for Exida. Exida has many former TUV engineers on staff. Perhaps even more important than experience is technical excellence, and we like to emphasize that very much. Exida has been very active on the functional safety and cybersecurity standards committees. I believe we have more functional safety standards committee experience than any other certification company. Many of the people at Exida have developed the 61508 analysis techniques. And of course, at Exida, as I pointed out, we publish these techniques, we publish our data, and we will and absolutely will continue to train even our competitors in how to use our tools and techniques. In the process industries, I do see that this slide's a little out of date, but in the process industries, we estimate Exida has done about 75% of all the certifications completed. Now, we were ignoring cycle test certifications that indicate low demand or that haven't followed accepted practices from the reliability engineering community. But we're quite proud of the fact that Exida has done a substantial quantity of process industry certifications. Excuse me. And of course, I think the list would look much better if we brought it up to date. Any other questions or comments? I see a question. I guess that's a question. I thought functional safety certifications had to be done by TÜV? Question mark. Well, first of all, yeah, the whole functional safety certification concept was absolutely started by two different companies calling themselves TÜV back in the mid-1980s. And today there are three companies in Germany, TÜV Nord, TÜV Süd, and TÜV Rheinland, which are actively involved in functional safety certification. Those three companies are competitors to each other, and they are a competitor to Exida. It might be that X, Y, and Z are those three companies, but you have to figure that one out yourself. Bottom line is, any technically competent company that has been accredited per the National Accreditation Body is a certification body for functional safety. In addition to those I've mentioned, I've seen CIRA out of the UK listed on an accreditation body website as being functional safety competent. I've seen a company in Japan, I can't remember the name now, as being cybersecurity competent. Exida has ratings in both functional safety and cybersecurity. If you're interested in any more information, we have the Open Certification White Paper and a pretty good, up-to-date paper on IEC 61508 Frequently Asked Questions. Both of these are available for free download on the Exida Resources area of the Exida webpage. I also wanted to point out that Exida does publish a book called Functional Safety, an IEC 61508 SIL 3 compliant development process. Now, this shows an example 61508 development process in language that means something to development engineers and software engineers, not the language used in the standard. Anybody know what a bespoke system is? Yeah, I didn't either for a long time. Anyway, to me, this book was published to give away all the secrets of successfully getting a 61508 certification. So if you are getting a 61508 certification and you can't make heads or tails of the actual standard, and you have no idea what you have to do, you can get training from Exida, of course, or you can spend just a little bit of money and get one of our books. It's available on Amazon.com or the Exida.com website. Any other questions or comments? I'm looking at my list here. I don't see any right now. You're a pretty quiet group. Well, let me just say that if you do have any other questions or comments, feel free to send an email. My email address is wgoble@exida.com. I can answer asynchronously. Sometimes it takes me some days to answer, but emails work very well for me. Let me say thank you very much for attending today, and I hope that you found your time well spent. Stay tuned for many other Exida web seminars coming up. We have one more this year, next Tuesday, and then a whole series are planned starting second week in January. Thank you for attending, and goodbye.